Hello, Curran here. This video is all about making this here Choropleth map with D3 and SVG. This is the Choropleth map we're going to build in this video. The color shows different categories of development, from developed region in G7 to least developed region. It also has tooltips, so you can hover and see what category a given country is in, and it also has panning and zooming. If you followed the previous video's cheap tricks for interaction and color and size legends, and you're interested in using color to encode data on a map, then this video is for you. The topics we're going to cover here include integrating topo.json data with tabular data from a TSV file, creating a load and process data module which factors out all the logic for loading and processing data, visualizing an ordered attribute with color, showing data from two attributes at once in the tooltip, and finally adding a color legend. I'm going to start by forking this cheap tricks for interaction example, and I'm going to rename it to Choropleth Map. I'm going to clear out the old content of the README, and then let's take a look at index.js. We're already loading these two files, one topo.json file and one TSV file, and this TSV data actually has some kind of interesting things in it. What I'm going to do is open up this TSV file in a spreadsheet program. What I'm going to do is just paste that URL in a new tab, which should download the file, and then I'll open it up. And for me on Linux, it opens in LibreOffice, but it should open in Excel or other programs too. So we've got a lot of columns here, and I'm looking for a column that might fit well with the Choropleth map. These two columns strike me as that they might fit really well. Economy and income group. The economy column looks like it divides countries into, say, 7 levels of categorization in terms of how developed they are. And similarly, income group divides countries into several categories, looks like 5, of income. So our goal is to use one of these to assign colors to the countries on the map. Let's go about integrating topo.json with tabular data. Going back to our code from earlier, remember that this code here, it copies the name for all of the countries over into this accumulator, which gets assigned to be country name. And so you can look up the name of the country like this, country name at d.id. And remember, this goes into the text for the tooltips. But what we need to do here is actually access some other columns, not just d.name. So what we can do instead here is, instead of just copying over d.name, we can copy over D, the whole row, and then when we access that row, we can say .name. Now the tooltips should still work, yep. But this variable name is no longer accurate. I'm going to call it row by ID, because it lets you look up one row of the TSV data by the ID from the topo.json. So we've got row by ID. Now we can use row by ID at d.id.name for the tooltips. But you know what? I would rather just say, d.name or d.properties.name. I really don't like this having to look up something in a separate table inside of our DOM manipulation code. So I'm going to do a slight refactoring where we do this lookup separately in like a pre-processing step. It'll simplify our visualization code. So after we define countries here, I'm going to loop through all the countries with countries.forEach. Or actually, no, sorry, it should be countries.features.forEach. And for each of these features, I'll call it D, it already has d.properties. So what we can do is sort of fill out d.properties by looking up the row by ID. So we've got the row by ID and we've got properties, and what we want to do is take all the properties from this object and assign it onto this object. And to do that, we can use object.assign. If we say object.assign d.properties row by ID d.id, now d.properties will contain all of the properties from each row of the table, and instead of doing the lookup here, we can just say d.properties.name. All right, now when we access d.properties.name, it should still work. So if I hover, yeah, the tooltips, they still work. And just as a sanity check, if I comment that out, then they don't work anymore. Okay, so far so good. I'm going to get rid of this dead code here. All right, so now what we want to do is set the fill color. We can say .attr fill to be something. I'll just set it to like red, just to make sure that we have control over the fill in the JavaScript. And it looks like we don't right now. See, it's not turning red. And this is because in the CSS, we're setting the fill of the country polygons to be light green. And apparently, if you set the fill in CSS, that takes precedent over the fill attribute. So if I get rid of this fill in the CSS, okay, now we have control over the fill color from JavaScript. And before we move on, this file is getting pretty big and it's doing a lot of things. Let's create a load and process data module. So what I'm going to do is refactor this logic that loads and parses the data into a separate module. And we can call it load and process data. And that can return a promise. So we can say .then, and that promise callback can take as input countries. Yeah, that would simplify this file nicely. So let's make that module. We can import load and process data from load and process data.js, which is a new file that I'm going to create. Load and process data.js. So I'll create that, and then in that file I'm going to paste that logic that I had copied earlier. And we should actually export this as a function. So we can say export const load and process data equals a function that returns a promise. So I'm not going to use the curly braces here, but instead I'll just indent this. So it's going to actually return this promise.all.then, and then this code needs to be completed here. This should actually return countries, and then we need to just close out that statement there. And I'll just change the formatting to make it more clear what's going on here. We have promise.all as one sort of thing that's going on, and then we have the .then as another thing that's going on. And I'll indent that as well. And in this file, we're using feature from topo.json. So I'm going to move this import feature from topo.json from the index.js into this file here, load and process data.js. And I wonder why this is not working. I'm going to open up the DevTools and take a look. Ah, yes, TSV is not defined. So we're using TSV. We've imported TSV from D3 in index.js. So I'm going to move that import over to here, load and process data. We can just import TSV and nothing else from D3. Oh, and JSON also we need. So import TSV and JSON from D3. Now it's working again. And in index.js, we no longer need to import JSON from D3. All right, so that's how you can factor out a function that loads and processes the data. And now we can just develop our visualization code here, and that's sort of tucked away in a separate module. Okay, so now we can resume setting the fill based on data. And just to get started here, I'm going to create a color scale. Const color scale is an instance of scale ordinal, and we need to import scale ordinal from D3. And I'm going to set the range of this scale to be scheme category 10. And scheme category 10 we also need to import from D3. This is a set of 10 nicely chosen colors that are just different from one another. They don't have any ordering, they're just different hues, essentially. Now let's visualize this ordered attribute with color, where the color is ordered as well. Now we can use color scale to define the fill color. So for the fill, we can take as input D and return color scale of, well, let's try d.properties.name, something we know exists. And we get this nice map where all the colors are just different from one another. But what we really want to do is visualize one of those rows that we thought about earlier. So if I go back to the spreadsheet, what was that? Let's try this one, economy. So going back to the code, we can say d.properties.economy, and we see now we get a different set of colors. But the thing about d.properties.economy is that it's actually ordered. And what we can do is we can set the domain of the color scale. We can say color scale.domain, and we just get all the different values for economy. We can say countries.features.map, and we can map over a function that takes as input D and returns d.properties.economy. And we've got some duplicated logic here already. This function that takes as input D and returns d.properties.economy, I'm going to factor that out into another variable called color value, a value accessor. That just returns d.properties.economy. And we can use this function here in map and also here when we define the color. So we can say color scale of color value of D. And just out of curiosity, I'd like to see what these values are for the color scale domain. So right here I can say console.log color scale.domain, and if you access domain as a function, it just returns the domain if you don't pass anything in. All right, if we open up the console here, this is what we see. These different values, and they're not in the right order, but notice that there's no duplicates. If you set the domain of an ordinal scale and you pass in an array that has duplicates, like this one here, it automatically sort of deduplicates everything and just gives you the unique values. So what I'm thinking we'd like to do here is, sort these by their number and then assign them colors on the map where the luminance varies. So first of all, let's sort these. If we just say .sort on this array here, I think that should work. Yeah, all right, that's perfect. So I think what we need to do here is, instead of console.logging the domain, we need to set the domain again like this. And this maybe, it feels a bit weird, but I think it's the best way to do it, because we're taking advantage of this invocation to sort of boil down all the duplicates to just a small array of length 7. I mean, we could do the sorting in here, but then it would be sorting the whole array, which we don't really need to do. Like, it's more computation than necessary. So we're setting the domain twice, once to get rid of the duplicates, and a second time to sort the values. And this logic could be simplified a little bit with chaining. So we can phrase it like this. All right, so now we're assigning different colors based on what these values are. But the colors themselves have no order to them. It's just scheme category 10. So let's go over to the D3 Scale Chromatic package and take a look at what our options are over there. This is the package where the various schemes are defined for D3. See, here's scheme category 10. Here's some other schemes. Here are some diverging schemes, meaning they go to two different colors. So let's think about how color should encode these values. I mean, we have least developed to, I guess, most developed. So maybe we could use a scheme like this, where least developed is dark red here, medium developed is this sort of benevolent yellow color here, and then most developed is this blue color. That could possibly work. So let's try this, scheme spectral. And what this notation here means is that if you access scheme spectral at, say, 3, so scheme spectral is an array, and if you access scheme spectral at, let's say, k of 3, it would give you 3 different colors. This one, and this one. But what we want to do here is access the version that has, I think, 7 colors. So let's try that. Let's give it a try. Yeah, the length of our array is 7. So instead of scheme category 10 here, I'm going to use scheme spectral at index 7. And we need to import scheme spectral from D3. And look at that. I think it's working, although it appears to be inverted from what we were after. And by the way, I don't really like using this constant 7, because if we change the color value accessor, then this number won't hold anymore. So what we could do instead is hold off on specifying the range until we have access to the data. And then here we could set the range to be scheme spectral at index 7. Oh, I moved that semicolon. But instead of using 7, we could actually access the length of the color scale domain by saying colorscale.domain.length. That's a property on all arrays. All right, great. And if we want to invert this mapping, we can just reverse the domain. That would have the desired effect. So we can just call .reverse on that array there. And now the least developed countries are red, and the most developed countries are blue. And I would like to be able to hover over this and see the values that we have here. Let's show the data from these two attributes in the tooltips. So let's do that. Let's just modify this tooltip function to include the color value of D. So I'm going to say, all right, d.properties.name, the country name, plus maybe a space, or like a colon space, and then plus color value at D. Now if we hover over, we can see that, okay, these are the least developed regions. These are developing regions. These are emerging regions. And in Europe, we've got developed regions. But what I would really love to see is a color legend, so that you don't need to hover to understand what each of these things mean. All right, let's add a color legend. I'm going to make a new file, and I'm going to call it colorlegend.js. And I'm going to go to that color legend example from earlier. Here it is, color and size legends. Yeah, well, let's just use this color legend component. And it's already here, colorlegend.js. So I'm just going to copy all this logic into our brand new colorlegend.js. And let's see, how is this invoked? In the index.js of this other example, we have a color scale. It's a scale ordinal. And then it's being invoked right here. So, I'm just going to copy paste this logic where we append a group element, set its transform, and then invoke the color legend. I'm going to copy that over to our map example. So over in our index.js, let's think about where we want this to be and what we want to have happen when you zoom. I think when you zoom, the color legend should probably just stay put. So that means we should append a new group element to our top level SVG. So I'm going to go about doing that. I'm going to paste that logic we had from earlier, where we append a group element, set its transform, and then call the color legend with the color scale. But the problem is we don't have the color scale defined quite yet. So what I'll do is split this into two statements. Let's make a new variable, color legend G, meaning this is the group that will contain the color legend, and we can set the transform attribute there. And then later on, when we have the color scale defined, we can say color legend G dot call color legend like this. So I'm going to move this logic down to this area down here where we have the color scale set up. So right after we set up the color scale, we can invoke our color legend. And I don't think we've imported color legend yet, so let's go ahead and do that. So we can import color legend from /color legend. And we should be seeing a color legend. Oh, there it is. It's behind the map. And see, we don't have our styles from the other example, so before doing anything else, I'm going to copy over the CSS. In our color and size legends example, here's the CSS for the tick text and the tick circles. So I'm just going to use that. Over in our styles.css here, I'm just going to paste that CSS. So now we have a nice color legend, although it's behind the map. So let's put the color legend above the map. If we go back to index.js, see where we're appending these things? We're appending the color legend group first before this G that has the map on it. And what we can do to make it appear above the map is to just move this to be after we append this group element. So I'll just put that right there. Now the color legend is on top of the map, but it's like too much so on top of the map. I kind of want to like put a white box around this and make it smaller, put it in the corner, put it like over here in the middle of the ocean so it's not overlapping any of these countries. So first, let's do what we can by tweaking the props that we pass into the color legend. The circle radius should be smaller, first off. Let's say 10. We've got small circles. And then the spacing should also be smaller, like maybe 30 pixels. Yeah, and the text offset can be smaller too, maybe 10 pixels. Or, I don't know, 12. And the text is too big, and that's something we can control from CSS. We've got this tick text block right here, so we can just tweak the font size to be, 0.3 EM. Oh, that's too small. 0.9, maybe 1 EM, maybe 1.4. And then let's just move that off the countries. We can do that in index.js by setting the translate of our color legend group and just tweaking this. So yeah, I'll just tweak these X and Y until it's in the corner. And the text still overlaps some countries, so I'll do another pass on these props. I'll set the spacing to 20 and the circle radius to, say, 8. Now over in the CSS, we can make the text even smaller. 1 EM looks okay. And now let's add like a white rounded rectangle around this whole thing. And we can do that in colorlegend.js. Say const background rect equals selection.select all G, although this is going to conflict with this other one where we're selecting the tick classes. So I'm going to change this other statement to, instead of selecting G's, we're going to select all the .tick group elements. Although, you know what? We don't need to select all group elements. We need to select all rect elements. We're going to have rectangles here. And then we can say .data is the special case of one thing. So I'm going to use null there. Then we can say background rect.enter.append rect.merge background rect. And now we can set our .attr width of, say, 100, and also height of 100. See, we've got this sort of nasty black square. I would like to make it white, so we can say .attr fill is going to be white. And see how it's aligned with the center of our circles? We want it to be sort of out here, so we can set x and y. .attr x. And if we set x to a negative number, maybe -10, see that moves it to the left. And I think a good value here would be minus circle radius times 2. Yeah, that'll give us plenty of space. And we can do the same for y. Just copy paste that, change x to y. And the height, we should be able to infer from the number of elements. This is actually going to be spacing times the number of elements. And since we're using colorscale.domain, we can say colorscale.domain.length to get the number of elements. And since we're subtracting circle radius times 2 from here, we should actually add it down here. So we can say plus circle radius times 2. See, that gives us the same spacing on the bottom as we have already on the top. But now this line is too long, so I'm gonna call this n, and we can say const n equals colorscale.domain.length. And then the width, well, that really depends on the text. I think I'll just make this configurable. So I'll call it background rect width. And background rect width we can take from the props, and over in index.js, when we call the color legend, we can specify background rect width to be, let's say, 200, and then now we can tweak it until it's approximately what we want. Yeah, 235 looks pretty good. And I just want to add a couple subtleties here, like, I don't know, rounded edges, and we can make it slightly transparent. So over in our color legend.js, we can set the attribute rx, the roundedness of the edges. And let's try setting this to circle radius. Yeah, that gives a nice rounded feel. And if we use circle radius times 2, yeah, that looks even nicer. And we can set the fill opacity by saying .attr opacity of, let's say, 0.5, maybe 0.8. And now that we're not on a white background, I think I'd like this text to be actually black. So I'm going to change the fill of the text to be black. All right, that looks reasonably good. Now we can sort of take a step back and actually just look at the visualization. It's amazing how so many African nations are considered least developed, but a couple stand out. I mean, here's Nigeria, it's an emerging region, and also Kenya as an emerging region, and also South Africa and Zimbabwe. I find that pretty interesting. And in North Africa, we've got Egypt, also as an emerging region. And this distinction here is interesting. Developed region G7 and developed region non-G7. See, this, just looking at these two colors is kind of interesting, you know? Like Australia is non-G7. And also all these countries along here, you know, Romania, Hungary, Slovakia, Poland, And also Sweden and Norway are non-G7. And we've got an interesting situation over here with the Koreas. See that? North Korea is considered a least developed region, whereas South Korea is considered an emerging region. And here's Japan, a developed G7 region. So quite a contrast right there. Another interesting contrast is Saudi Arabia here, considered a developed region, non-G7, in the midst of all these, least developed regions like Yemen, Oman. Pretty interesting. Israel, developed region, non-G7. Very interesting. And you can clearly read the G7 countries: Italy, France, Germany, and the UK. But not Ireland, not Spain, not Portugal. So I'm pretty happy with this as an end product, but I remember there was another column of that table, and that was income group. So I'm just curious, what if we visualize this instead? So if we go to index.js, I think all we're going to have to do is just change this one thing here, color value. Instead of accessing economy, if we access income group, see that? Everything automatically updates, including the legend and the height and the colors and everything. That's all for Choropleth Map with D3 and SVG. Thanks for watching. Take care.